नमस्कार, आप सभी का बहुत बहुत स्वागत है। आप देख रहे हैं पीएम ई विद्या चैनल नंबर 10 और NCERT ऑफिशियल यूट्यूब चैनल। इसके अलावा आप हमारे अन्य यूट्यूब चैनल के माध्यम से भी जुड़े हैं, जो है NCERT पीएम ई विद्या क्लास नंबर 10। इन सभी माध्यमों पर आप सभी का स्वागत करती हूं मैं रेणु भट्ट अपने इस लाइव इंटरेक्शन में, जिसमें हम बात करेंगे साइंस के 10th स्टैंडर्ड स्टूडेंट्स के लिए। आपको अपनी टेलीविज़न स्क्रीन पर नज़र आ रहे हैं हमारे साइन लैंग्वेज इंटरप्रेटर। चलिए आप सभी का परिचय करवाना चाहेंगे उनसे। आप हैं श्री आशीष गहलोत। आशीष, आपका बहुत बहुत स्वागत है। और जैसे हमने अपने सभी देखने वालों को बताया कि हम बच्चों इस सत्र में बात करने वाले हैं साइंस के 10th स्टैंडर्ड स्टूडेंट्स के लिए। एंड द टॉपिक दैट वी हैव टुडे टेकन अप फॉर दिस पर्टिकुलर सेशन इज़ मैग्नेटिक इफेक्ट ऑफ करंट। हम इस टॉपिक पे बात करने वाले हैं और मैग्नेटिक इफेक्ट ऑफ करंट क्या होता है और मैग्नेट की क्या प्रॉपर्टीज़ होती है, मैग्नेटिक कंपास कैसे इस्तेमाल किया जाता है, मैग्नेटिक फील्ड लाइंस क्या होती है, ये और बहुत सारी बातें हम जानने वाले हैं अपने आज के इस सत्र में। तो जानेंगे अपने एक्सपर्ट से। एंड वी हैव जॉइन बाय आवर एक्सपर्ट। तो चलिए आप सभी का परिचय करवाना चाहते हैं उनसे। आप हैं मिस पूजा जैन, आप TGT नेचुरल साइंस हैं, GSKV स्कूल से, आप शास्त्री पार्क दिल्ली से हैं। मैम, आपका बहुत बहुत स्वागत है, वेरी वार्म वेलकम। अपने सभी देखने वालों को बोलना चाहेंगे कि इन केस यू हैव एनी क्वेरी और क्वेश्चंस रिलेटेड टू दिस पर्टिकुलर टॉपिक, आप हमें कॉल कर सकते हैं हमारे टेलीफोन नंबर पे, दैट इज़ 8800440559, या फिर आप हमें ईमेल करें। हमारा ईमेल एड्रेस है dth.class10@cit.nic.in। जब भी आप हमें ईमेल करें अपने फीडबैक के लिए, तो आप अपनी इस सत्र की डिटेल ज़रूर उसमें ऐड करें। यूट्यूब चैनल्स पे हैं तो लाइव चैट बॉक्स में जाकर आप कमेंट ड्रॉप कर सकते हैं। तो ये तमाम माध्यम है हमसे जुड़ने के। आपको अपनी टेलीविज़न स्क्रीन पर स्क्रॉल के रूप में भी नज़र आ रहे हैं। तो जब तक आप हमसे जुड़ते हैं, हम अपने आज के सत्र शुरू करना चाहेंगे। पूजा मैम, हम आपके पास आएंगे और हम आपसे जानना चाहेंगे कि हम मैग्नेटिक इफेक्ट ऑफ करंट की बात करने वाले हैं आज इस सेशन में, आपसे जानने वाले हैं। सबसे पहले हम ये जानेंगे कि इस टॉपिक के अंतर्गत आप कौन कौन सी बातें हैं, कंटेंट है जो आप हमारे बच्चों के लिए लेकर आए हैं।
Today we will discuss about magnetic effect of current, magnet, properties of magnet, magnetic field lines, how magnetic field lines are formed, properties of magnetic field lines, magnetic Oersted experiment, magnetic field lines around a straight conductor, circular loop, and solenoid, and practical application of magnetic effect of current in our daily life.
And that is, I guess, quite important.
Yeah, it's very
much important to know about the practical applications. So, ma'am, we'll start with the question. We are talking about magnetic effect of current. What exactly magnetic effect of current is?
Magnetic effect of current, when current is passed through a conductor, straight current carrying conductor, then this conductor behaves like a magnet. This is called magnetic effect of current. Suppose it is a conductor and current is passing through it, it will behave like a magnet. But before understanding the concept of magnetic effect of current, we have to understand what is magnet.
Right.
A magnet is a substance that attracts pieces of iron, nickel or cobalt towards it.
मैम, हम आपसे रिक्वेस्ट करेंगे कि आप अगर नीचे रखे बच्चों को दिखाएंगे, तो दैट वुड बी मोर इजी टू अंडरस्टैंड व्हाट मैग्नेट इज। यस मैम।
It's a magnet, and magnet is a substance that attracts pieces of nickel, iron or cobalt towards it.
Okay.
There are different types of magnet. It is a bar magnet. It is a disc shaped magnet.
Okay.
Disc shaped magnet. It is a circular magnet. It is a horseshoe shaped magnet. So properties of magnet. What are the properties of magnet?
मैम, यहाँ पे मैं आपसे जानना चाहूँगी, जैसे आपने बताया कि डेफिनेटली हम प्रॉपर्टीज़ जानेंगे, तो हमारे पास मैग्नेट्स तो हैं, इनकी शेप्स अलग अलग हैं, तो क्या इन शेप्स के यूजेस भी अलग अलग हैं? इज दैट सो?
यस मैम।
ओके, ठीक है। तो मैम, हम जानेंगे अब इसके प्रॉपर्टीज़ के बारे में।
ओके। magnet always has two poles, one north pole and one south pole. When a magnet is suspended freely with the help of a thread, it always points in north-south direction. Its north pole points towards the geographical north of the earth, and its south pole points towards the geographical south pole of the earth.
Okay.
Opposite poles of the magnet always attract each other. You can have a look that it is a south pole, it is a south pole and it is north pole. So these two poles are attracting each other. But when we put similar poles of the magnet towards each other, they always repel each other. It is impossible to to attach the two poles because they always repel each other. Unlike poles repel each other, and similar poles repel each other and unlike poles always attract each other.
तो ये तो रही प्रॉपर्टीज ऑफ मैग्नेट. यहाँ पे हम जानेंगे कि मैम हाउ कैन अ मैग्नेट कैंपस कैन बी यूज्ड.
Yes, ma'am. A magnet has magnetic force in the form of attraction or repulsion. So this attraction or repulsion can be felt with the help of magnetic field. So what is magnetic field? Magnetic field is a space round a magnet in which its attraction or repulsion can be felt. But how this attraction and repulsion can be felt? Suppose it is a bar magnet, I am keeping it on the cardboard and I am taking another magnet closer to it. So when I am keeping it nearby, it is attracting, strongly attracting. But when I am slowly taking this magnet away from the magnet, I am observing that its attraction doesn't work. It means that its magnetic field is only up to this space. It can be understood with the help of a compass. Whenever a compass, what is a compass? A compass is a tiny magnet that is enclosed in a glass container and it is pivoted at the center so that it is free to move. Its one end points towards the north and is called North Pole, and its another end points towards the south and it is called South Pole. So whenever a compass is brought near a magnet, it always deflects, showing the presence of another magnet. It means one magnet is applying force on another magnet, that's why it deflects. So magnetic.
Ma'am, I would request you to have that compass on page, ma'am.
Yes, ma'am.
On frame. Yes, ma'am.
Yes, ma'am. It's a magnetic compass, and whenever you can see its deflection, whenever a magnet is brought closer to the magnetic compass, it always deflects, its needle deflects. It shows, its deflection shows that there is a magnetic field nearby.
Okay. So ma'am, what are magnetic field lines, ma'am? Could you please explain?
Yeah, ma'am. Magnetic field lines are the imaginary lines that we use to represent the magnetic field. मैग्नेटिक फील्ड को रिप्रेजेंट करने के लिए कुछ इमेजिनरी लाइंस का प्रयोग किया जाता है जिनको हम मैग्नेटिक फील्ड लाइंस कहते हैं. लाइक आई एम हैविंग दिस मैग्नेट, आई एम कीपिंग इट ऑन द कार्डबोर्ड and we are doing an activity. Let's understood with the help of an activity.
Okay. So ma'am, could you please tell us about, okay, it's iron powder,
yeah,
right? Okay.
I am sprinkling some iron filling around a magnet. You can see that you just do nothing. You have to just tap the cardboard gently.
Okay.
After some time, you will see that a particular pattern has formed. These iron fillings will arrange themselves in a particular pattern. This pattern that is followed by iron filling, these are the magnetic field lines. Magnetic field lines can also be observed with the help of a compass. So you can have a look, ma'am. The iron powder has arranged itself in the form of closed curves. So magnetic field lines are closed curve. Outside the magnet, magnetic field lines always move from north pole of the magnet to south pole.
Okay.
Inside the magnet, magnetic field lines move from south pole to north pole. It represents a uniform magnetic field. Inside the magnet, magnetic field lines are parallel. But outside the magnet, magnetic field lines are non-uniform. At some places, magnetic field lines are crowded. At some places, magnetic field lines are far apart. So the place where magnetic field lines are crowded, it represents a strong magnetic field. The degree of closeness or crowdiness of magnetic field lines represents the strength of magnetic field.
Okay.
More the magnetic field lines, more will be the magnetic field. So you can have a look, ma'am. The magnetic field lines are crowded at poles. So the strength of magnet is maximum at poles.
Okay. तो poles की तरफ ज़्यादा रहेंगे.
Yeah, ma'am. Yeah.
Okay, fine. So ma'am, that was about the magnetic field lines, right? Ma'am, could here we want to know about the relationship between magnetism and electricity, ma'am.
Yes, it was a very interesting experiment. In 1819, there was a Danish physicist. His name was Hans Christian Ørsted. Once he was doing experiment in his lab, and suddenly he observed that when a current carrying conductor, when a compass was brought near a current carrying conductor, there was a strong deflection in the compass. Okay. You can see that as the current is on, the compass shows a deflection. It is an It is an electric circuit and the current is flowing through the circuit. So he was surprised to know that as the current was on, there was a deflection in the compass. It means that there is a strong relationship between magnet and magnetism and electricity, because a magnetic compass deflects only in the presence of magnet, but here is no magnet. Here only the current is flowing through the conductor. It means that current is behaving like the magnet. It is magnetic effect of current.
Okay. तो मैम दैट वाज द एक्सपेरिमेंट. हमारे बच्चे जो है अपनी क्लास में भी कर सकते हैं, स्कूल में भी दे कैन परफॉर्म दिस एक्सपेरिमेंट. मैम यहाँ पे हम आपसे जानना चाहेंगे, हमने और स्टार्टिंग में भी आपने प्रैक्टिकल एप्लीकेशंस की बात की, राइट? तो वी आर वेरी क्यूरियस टू नो अबाउट द प्रैक्टिकल एप्लीकेशंस. क्या क्या है ऐसे एप्लीकेशंस जो आप बताना चाहेंगे? और इससे पहले अगर कुछ और भी आप बताना चाहते हैं हमारे स्टूडेंट्स को, तो प्लीज़ मैम आप उनके साथ शेयर करें.
Magnetic effect of current has wide applications in our daily life. We are sitting in a studio and we are using the loudspeaker and speakers. All these are using the magnetic effect of current. Loudspeakers produce vibrations. Loudspeakers use electromagnets to create vibrations, and this produces sound. And apart from this, many objects in our home like motors, like machines, like electric fan, all these use electromagnets. And all these work on the concept of magnetic effect of electric current. Moreover, doorbells, electric bells in schools, and cranes that are used to lift such a heavy load. All these use magnetic effect of current. Moreover, in hospitals and in medical sciences, MRI, medical resonance imaging, it also use the concept of magnetic effect of current. So there are wide applications of magnetic effect of electric current in our daily life. Magnetic effect of current is used in one or another form in all day-to-day products like electric fan, motor, mixer, grinder. All the motors works on the concept of magnetic effect of electric current.
Okay. तो ये तो बात हुई हमारे इलेक्ट्रिकल गैजेट्स जो हैं.
Yes, ma'am.
हम उनको ले सकते हैं इस चीज़ के अंदर, यानी कि प्रैक्टिकल एप्लीकेशंस में हम उन्हें काउंट कर सकते हैं. मैम यहाँ पर हम आपसे जानना चाहेंगे राइट हैंड थंब रूल के बारे में. आप ये इसके बारे में बताना चाहें, और इसके अलावा अगर कोई और बात भी आप शेयर करना चाहते हैं तो प्लीज़ शेयर मैम.
Yes, ma'am. Now we have studied from Oxford experiment that there is a strong relationship between magnetism and electricity. It means a current carrying conductor behaves like a magnet. So if it behaves like a magnet, there should be magnetic field lines, there should be poles. So the magnetic effect of current, magnetic field, we have to study the magnetic field around a straight current carrying conductor. It is a straight current carrying conductor. Suppose current is passing through it, we just pass it from a cardboard and sprinkle some iron powder around it. We will see that there magnetic field lines will be formed, and these magnetic field lines will be in the form of concentric circles. So magnetic field lines around a current carrying straight conductor are in the form of concentric circles. When current is flown in this conductor, concentric circles are formed, and the factors on which the magnetic field depends are current, and that magnetic effect of current is only due to the presence of electric current. So as we increase the magnitude of electric current, the magnitude of magnetic field also decreases, and if we decrease the current, magnitude of magnetic field also decreases. And magnetic field lines are in the form of concentric circles. As we move away from the conductor, as we move away from the current carrying conductor, as the radius of the concentric circles increases, the magnitude of magnetic field decreases. Magnitude of magnetic field produced by electric current decreases with increase in distance. The size of concentric circles of magnetic field increases with distance from the conductor, which shows that magnetic field decreases with distance.
Okay.
So here is a right hand thumb rule. According to this rule, imagine that you are holding a current carrying conductor in your right hand. It's my right hand, and I am carrying a current carrying conductor in my right hand in such a way that your thumb represents the direction of current. My thumb is pointing upward, it means direction of current is upward. Then your curled fingers, the direction in which your fingers are wrapped, will give the direction of magnetic field lines. Now you can see that my fingers are curled in anti-clockwise direction. So this, when current is moving upward, the magnetic field lines will be anti-clockwise. It is right hand thumb rule. Right hand thumb rule gives the direction of magnetic field around a straight current carrying conductor. Now if I am keeping it downward, suppose current is flowing downward. Now you can see that my thumb indicates the direction of current in downward direction. Now my fingers are curled clockwise. It means direction of magnetic field lines will be clockwise. The concentric circles will be formed clockwise. It is right hand thumb rule. It was given by scientist Maxwell. That's why it is also known as Maxwell right hand thumb rule. It gives the direction of magnetic field lines around a straight current carrying conductor.
Okay.
Now
anything else that you
yeah,
want to add
now
on?
the
Yes,
current, it's not necessary that always we have a straight conductor. The conductor can be in the form of a coil. So what is a coil? When straight wire is bent in the form of circle, it is called a circular coil. It is a circular coil, right? So when current is passed through a circular coil, the magnetic field produced are in the form of concentric circles around the conductor. Because each and every point of circular coil behaves like a straight conductor. So concentric circles are formed at each and every point of the circular coil. And towards the center, the arcs of the circle become larger and they merge and appear as a straight line. It means in a circular coil, all the concentric circles merge at center and the magnetic field is maximum at the center. Magnetic field lines are formed in the form of concentric circles, but these concentric circles merge at center and the magnetic field strength becomes maximum at the center. So when a circular coil is behaving like a magnet, it must have poles. It must have north pole, it must have south pole. So for knowing the direction of poles, we use clock face rule. What is clock face rule? It is a circular coil, and if the current is flowing clockwise, then this face of the coil will behave like south pole. But if the current is flowing anti-clockwise, then this face of the coil will behave like a north pole. Now we will understand the factors on affecting magnetic field of a circular current carrying conductor. As you know that magnetic field is only due to the presence of current. So magnetic field is directly proportional to the current. As we increase the amount of current, magnetic field will be increased. Magnetic field is inversely proportional to the distance from the conductor. As we increase the radius of coil, the magnetic field will be decreased. Magnetic field is directly proportional to the number of turns in the coil. As we increase the number of turns, suppose it is a coil and I am increasing the number of turns. So as we go on increasing the number of turns, the magnetic field will be maximum. So magnetic field is directly proportional to the number of turns in the coil because it is additive in nature. Magnetic field is additive in nature. More the number of turns, more will be the magnetic field. Clock face rule, it is used to know the direction of poles in a circular coil. A current carrying circular loop behaves like a disc magnet, and the polarity of magnet can be easily understood with the help of clock face rule. If the current is flowing anti-clockwise, then the face of the loop will show north pole. On the other hand, if the current is flowing in clockwise direction, then the face of the loop will show south pole. Now the current carrying conductor can be in the form of a solenoid. So what is a solenoid? A solenoid is a circular coil of wire in the shape of a cylinder. It is a yes, it is a solenoid.
Okay.
Yes, you can see that.
So ma'am, here we can't see. हम request करेंगे आपसे कि आप बोर्ड के ऊपर रख के दिखाएंगे तो that would be more easy to see.
Sure. It is a solenoid.
Okay.
when a circular
Spring-like.
coil of wire is wrapped in the form of a cylinder, in the form of a spring, it is called circular coil. It is called solenoid. When current flows through a solenoid, it behaves like a bar magnet. Magnetic field lines are formed in the form of a bar magnet. The end of solenoid behaves like north pole and south pole of the magnet. One end of the solenoid in which current flows in clockwise direction will behave like south pole, and the other end of the solenoid in which current flows in anti-clockwise will behave like north pole, and the magnetic field lines are formed just like bar magnet. Magnetic field lines emerge from north pole and merge into the south pole. But inside the solenoid, magnetic field lines move from south pole of the magnet to the north pole. Inside the solenoid, magnetic field is uniform at each and every point because magnetic field lines are parallel inside the solenoid. But outside the solenoid, magnetic field is non-uniform and magnetic field lines are crowded at poles. So, north pole and south pole has a maximum strength. Factors on which magnetic field due to a current carrying solenoid depends. The strength of magnetic field depends on the strength of current, as it is quite obvious, more the current, more will be the magnetic field. We are studying magnetic effect of current. It means the magnetic effect is only due to the presence of current. So, as we go on increasing the amount of current, magnetic field will be increased. Second point is number of turns in the coil. More the number of turns in solenoid, more will be the magnetic field, because magnetic field is additive in nature. More the number of turns in solenoid, more will be the magnetic field.
In a brief, ma'am, we would like to know about electromagnet.
Yeah, electromagnet. When a soft iron core is inserted inside a solenoid, it is a hollow solenoid, but when a soft iron core is inserted in it, it behaves like a electromagnet. Magnet formed by producing magnetic field inside a solenoid is called electromagnet. And electromagnets have wide uses, wide applications in our daily life that we have already studied, that electromagnets are used in electric motors, in machines, relay buttons, loudspeakers, electric bells, cranes, MRI, all these things use electromagnets.
Okay. So ma'am, anything specific your message that you want to share with our students that they need to keep in their mind?
Yes. First thing is that magnetic effect of current has wide applications. All the daily life products that you see in your daily life, all the things that you use like electric fan, all these work on magnetic effect of current. So, while preparing for magnetic effect of current, first keep the direction of current in mind, because magnetic field lines are dependent on current. As we increase the current, magnetic field increases. As we reverse the polarity of current, magnetic field lines, direction of magnetic field lines also changes. So, these are the key points that have to be kept in mind, that magnet and electricity are closely interrelated.
Okay. So, that was the important points that you need to keep in your mind, dear viewers, while reading this chapter. और अब हम अपने समाप्ति की ओर आ गए हैं, सत्र की समाप्ति की ओर. वी हैव टू रैप अप दिस सेशन. पर जाने से पहले हम मैम आपको, पूजा मैम, बहुत बहुत धन्यवाद करते हैं. थैंक यू सो वेरी मच फॉर बीइंग विद अस एंड फॉर दिस इन्फॉर्मेटिव प्रोग्राम्स. आई एम क्वाइट श्योर आवर लर्नर्स विल बी, हमारे जो जितने भी व्यूअर्स हैं, लर्नर्स हैं, उनको बहुत आसानी से, सरल तरीके से इस चैप्टर समझ में आया है और उनके लिए ये फ़ायदेमंद साबित होगा. और यहाँ पर आशीष, हम आपको भी धन्यवाद करते हैं और अपने सभी देखने वालों को धन्यवाद करते हुए हम आपसे एक बहुत ही इंपॉर्टेंट पीस ऑफ इन्फॉर्मेशन शेयर करना चाहेंगे. अगर आप 4th और 7th ग्रेड के NCERT की टेक्स्ट बुक्स ऑर्डर करना चाहते हैं तो यू कैन ऑर्डर इट फ्रॉम Amazon, Flipkart एंड फ्रॉम NCERT ऑफिशियल वेबसाइट. और हमारे अपने सभी देखने वालों को हम ये बता दें कि आगे आने वाले कौन से ऐसे सत्र हैं जो हम आपके लिए लेकर आए PME विद्या चैनल्स पर. और यहाँ पर हम आपको बता दें कि कुछ ही देर में अपने लाइव इंटरेक्शन के साथ हाजिर होंगे. ये उर्दू के 10वीं जमात के तलबा के लिए है. हमारा आज का उन्वान है खौल का पास. 4 बजे अपने ऑनलाइन प्रशिक्षण कार्यक्रम में हम बात करेंगे डेटा गोपनीयता की नैतिकता. इस पे 5 बजे सहयोग सत्र में आपको दिखाई दे रहा है कि किस टॉपिक पे हम बात करने वाले हैं. नीपा, आप ज़रूर हमारे सभी प्रोग्राम्स में जुड़े विद ऑल योर क्वेरीज एंड डाउट्स. अभी मुझे रेणु भट्ट को दे अनुमति, आप बने रहें PME विद्या चैनल्स पर और अधिक रोचक और ज्ञानवर्धक कार्यक्रमों के लिए. नमस्कार.